In this video, we're going to show you how to use Aspire's ability to slice a 3D object and also the ability to nest 3D components. We're going to start by importing a piece of 3D clip art that represents one side of a shark. We're going to scale that up and then we're going to use the slicing function to divide that into 3 pieces. We're then going to take those slices, make a copy of them so that we can create both a left and a right side for our shark, and then use the nesting function in order to create enough components to make 3 sharks. The nesting will also help us to evenly position those parts within our piece of material automatically. Finally, we'll show you how to generate vector boundaries on the slices we've created and the toolpaths that you'd need to cut them. Let's start by opening a new copy of the software. Let's begin by clicking on the icon to create a new file. We're going to set up a job which is just slightly larger than the shark that we want to slice. So I'm going to set the width to 25, height to 13. Material is going to be set so Z0 is off the top of the block and the thickness of the material is 1 inch, which is the same as the slice thickness that I'm going to use on our model. Date and position, lower left, working in inches. I'm going to set the modelling resolution to very high to retain as much quality as we can and click OK. I'm going to come down and click on the modelling tab because we want to import the 3D model of the shark. And up the top we're going to click on the icon here to import a component or 3D model. In the project folder for this example you'll find a file which is called vectorart3dshark.3dclip. And as the name would suggest there, this is one of the clip art models from the Vectorart 3D website. And click on open. We can see our shark has been brought into our job at its default size. And now what I want to do is scale that up. So I'm going to click on the icon here to set selected object size, and with the anchor set to the center, width I'm going to enter 24, link XY checked so that the height automatically scales. Hit apply, we can see that's resized. I can hit close, and then to center that I'm going to use the shortcut key, and that's F9, the function key F9 on the keyboard. When I press that, the selected object will be centered in the middle of my workspace. So now we've scaled and positioned the shark, let's click on the icon to tile the windows so we can see both the 2D and the 3D view simultaneously here. We can see the model looks nice, but I would like to give it more thickness before we slice it. So with the component selected, I'm going to click on the icon here to scale Z height of model, click on the button to set exact height, and I'm going to enter a height of 2.9 inches, hit apply. See how that looks in the 3D view. If I'm happy, I can hit close and I can hit OK. Now we've got everything sized correctly, we're ready to slice the model up into pieces that we can machine in our 1-inch material. The slice icon is located under the modelling tools on the 3rd row of icons here. If we click on that, then you can see that it'll give us some information about the model. It tells us that our current model is 2.9 inches thick, our material thickness is set to 1 inch, and by default the software will pick up that 1 inch material thickness and enter it for you as your slice thickness. You could change that value if you wanted by typing in something different if the slice thickness you were looking for with your model did not match your material thickness. In this case that is correct, we do want 1 inch slices, so I'm just going to click on the button here that says slice model. That'll take whatever I currently have visible, so any components that are currently visible, it will retain an original copy of those, and then it will create components, each one of which represents one of the slices that we've generated. If we want to, we can retain the original model in the part, just switch off the component. In this case we don't need to do that. I'm going to work just with the slices, so I'm going to right mouse click on that component and choose delete from the menu that appears. Now we're left just with the 3 slices that we created. If we want to click on each of these, you can see those highlighted in the 3D view that shows you each section that they represent in the shark. At the moment it looks like the original model because each of these is in its original position and is just being added on to the one below. If we switch these off, then we can see our lower slice, our lower 1-inch section there. Switch that off, switch on the middle slice, switch that off, and switch on the top slice, which will be a little bit less than 1 inch because the model was 2.9 inches thick. So we'll have two 1-inch slices and one slice which is 0.9 inches that represents the top part of the model here. I'm just going to switch those back on again. Slicing the part so that our job is just slightly bigger than the component has really allowed us to maximise the potential quality for each of those slices. Now though, we need to increase our job size in order to create a part which is actually the size of the piece of material we plan to cut, and then make copies of our slices in order to get all the components we're going to need for the finished job. So let's come down, click on the drawing tab, come up and click on the icon to set job dimensions and origin, and we're going to change the width of our job to be 48 inches, and then we're going to change the height of the job to also be 48 inches. So we're using a 1 inch thick 4 foot by 4 foot piece of foam for this particular part. I'm going to click OK. Now I'm going to click on the icon to tile the windows vertically because we've changed the size and orientation of the part here. That'll fit a little bit better on the screen. And I want to make a copy of these three slices and mirror them in order to create what is in effect the other side of our 3D shark that we're going to assemble. So I'm going to click and drag a box around this. I'm going to click again to go into the transform mode, and then I'm going to hold down Shift and Control and click in the middle and drag. Holding the Shift key down will make it drag vertically in line, and holding the Control key down means that when I let go, that instead of it just having dragged the original into a new position, it instead will have made a copy. Now we've got our copy there. I can come over, click on the icon to mirror selected objects. I want to uncheck Flip About Job Center, uncheck Create a Mirrored Copy, and then just click on the button here to flip horizontal and close. At this stage we could take these 6 components, lay them out in our part, create toolpaths, cut them into 1 inch material, and then have enough pieces to assemble one single model of a shark. In effect, we've got 3 slices that make up the left, 3 that make up the right, and then the 2 halves could be glued together. What I'd like to do though is have enough components where we could assemble 3 sharks. So let's come down and click on the modelling tab. What I'm going to do is just click on the white space to deselect, and then I'm going to click the first object in the component tree, and holding Shift down I'm going to click the last object in the component tree so we select all the components we have in our part. Now with those selected, we can use the nesting function in the software to help us make our multiple copies and to efficiently position those within our material. That's located on the Modelling tab under the Array Objects area. If we click on Nest Selected Objects, then we come into the form here, and what we need to do is give the software some information so it knows the parameters to work within when fitting the parts inside of our job area. First we need to indicate the largest tool that we're likely to use. So I'm going to use a 0.25 inch ball nose in order to machine these parts. I'm going to enter 0.25 for my tool diameter. I'm going to enter some additional clearance there to make the gap even wider between the parts as we nest them. So I'm going to put clearance of 0.25. Border gap's going to be 0. I don't mind the parts going right up to the edge of my job area. Now we have the option to let the software rotate the parts in order to help it fit them in. I'm going to enter a value of 90 for the moment. I do not want to allow the parts to be mirrored. We've already got our parts set up in the right orientation, so I don't want the software flipping them around, otherwise we may end up with parts that are going to be machined in the wrong direction and not be able to assemble our sharks correctly. We're going to nest from the lower left corner along X, and I want to specify 3 copies. So I'm going to take the set of components that we've selected there and make 3 copies of them, enough for us to assemble 3 full sharks. I'm just going to hit apply once I've entered that number. Now we can see if we look closely that it's labelled those with the number 3 now to show me how many copies of each I'm going to get. And at this stage we can come down and click on the button to preview what the nesting will look like. This is going to take all those parameters now and then do its best to fit our parts within our job setup area. Now you can see a message has popped up there telling me that it wasn't able to fit everything into our 4 foot by 4 foot work area. So what the software will do is automatically create multiple groups of components, and each of those will represent the parts that could fit on one sheet of material. So if I notice that, I could hit OK, and now if I was actually to exit out of the nesting, we'd see that we had two groups and we could switch those on and off to do the toolpaths. In this case, I think we could probably do better with the nesting by giving the software a tighter increment that it could rotate the parts in. So I'm going to enter a rotation step angle of 10, and this time I'm going to hit preview again to apply those new parameters and see if we can do any better. So there we can see that the software has been able to fit everything in by using that 10-degree increment into one sheet of material, into our 4x4 work area. I'm happy with that, so I can go ahead and hit OK to exit out of the nesting, and we can see all the different copies of our components now listed in the component tree. So we have 6 copies of slice 1, 6 copies of slice 2, and 6 copies of slice 3. It's worth noting that once components have been nested, you can still edit their positions manually. So if we saw there was a little more space here that the automatic settings of the nesting hadn't picked up, then we can always come in, click and select, click again to go into transform mode, and just drag these in order to create a little more space within our job area. So we don't need to do this because we know that the spacing is going to have left enough of a gap based on the settings that we used, but I just wanted to show you that it is possible to manually edit your nested components after the nesting process. They're not fixed in place. Before we create our toolpaths, we want to generate vector boundaries in order to contain them. The slicing presents an interesting situation because we have these flat areas on the slices, and because they're the thickness of the material, we don't really want to create a toolpath over the top of those. The most efficient way to cut each slice is just going to be to cut the 3D area around the side. So we're going to have to create a reasonably specialised set of boundaries, and to help me to do this, I'm going to group together some of our components. The ones that have this flat area on the top are slice 1 and slice 2. So I'm going to select the top component of slice 1, I'm going to select the last component of slice 2 in the list here, holding the shift key down so all the ones in between are selected. I'm going to click on the icon to group those selected objects, and we'll just right mouse click and rename that group as the slice 1 and 2 group. Now I'm going to select the first slice 3 component, shift and select the last one, right mouse click and group those together. You'll see in a moment why I've grouped those in this way. So first of all, I know I need a vector boundary around every single component to represent its outside edge. So I'm going to select both of the groups that we've got in the component tree, come up and click on the icon to create vector boundary from selected components. Now if I just deselect those, you can see it's fitted a vector around the outside of each of the 3D objects we had selected, and at the moment that's grouped together, which will come in handy later. Now the other vector boundary that I want to create is only going to be around the flat areas of the components that have those flat areas. Now they're only the components that were on slices 1 and 2, which is why I grouped these together in the way that I did. Now if I select that group, what I can do is use the grayscale and the function on the drawing tab to fit vectors to a bitmap in order to fit a vector around that top edge. I make sure that grayscale is selected for that group, click on the trace bitmap function, and within here I'm going to choose the white out of all the sets of greys that we've got listed. The white represents the highest area of the part and therefore basically is that top boundary of the slice. So with that selected, we can adjust the parameters in here. I'm going for around middle for loose to tight fit and around middle for the noise filter, and then go ahead and hit preview. The red color is showing me the area that that vector is going to be fitted to. If I'm happy with that, then we can just hit apply and close, and there we've got our set of vectors that represent the top edge of each slice. Now I'm going to do a little bit of vector editing before we go ahead and calculate the toolpaths. So to make it easier to select what I want, I'm going to come back to the Modelling tab and just click on the checkbox here to undraw all the 3D components. Now what I want to do is group together that set of vectors that represents the top edge for each slice. Easiest way to do that is going to be to come up, say Edit, select all vectors, and then to just hold the Shift key down and deselect the group that represents the outer edge. Now I just have those vectors that represent the top edge selected. I can come over and click on the icon to group them. The other edit I want to make to the vectors is to make sure the tool has enough room in order to fit down the sides of the part. Normally we'd do this by using the boundary vector offset in the toolpath form itself, but in this case I don't want to offset the top edge, I only want to offset the bottom edge. That way the centre of the tool will just roll up to the top edge, but then if we offset this bottom one, the centre of the tool will be able to go past and make sure that the side of the tool machines all the way down the side of our 3D components. So I'm going to select the group of vectors that represent the bottom edge of each of our slices of material. We're going to come down to the Drawing tab, click on the icon to offset the selected vectors. I'm going to offset these outwards, and I'm going to set a difference that's a bit bigger than the radius of the tool that we plan to use. So I'm going to enter a value of 0.15. I'm going to click the option to delete original and make sure I have the option selected to select new vectors. Let's click offset. So there's our new set of vector boundaries. Now I can go ahead and hit close, and while they're still selected I'm going to come down and click on the icon to group selected objects. So now we've still got a group that's our bottom boundary offset, and we've got a group that represents our top boundary. Now I'm ready to start calculating the toolpaths, other than I need to draw my 3D objects back again in the 3D view. So let's come down, click on the Modelling tab, check the box next to where it says Component Tree so our 3D components appear again, and at this stage we can click on the icon to switch to the Toolpath tab. That'll hide my Design tab, and on the right hand side it'll open up our toolpath icons. So the first job is to check our material setup before we calculate any toolpaths. And as with any job that have toolpaths in, if you do plan to cut a version of this yourself, make sure that all the parameters you enter suit the tooling, machinery and material that you're planning to use. Let's click on the Set button, and in here we're going to check Z0 set to the top of the block, thickness of my material is 1 inch, XY datum lower left. There's no gap because the thickness of my components is exactly 1 inch as well, so they're going to fill the entire piece of material. As such, I need to make sure that I would be holding this down in such a way where I'm not expecting to leave tabs or anything like that. So maybe I'd be using a vacuum, or I'd tape it, one of those sort of methods. Otherwise the parts will be released because we are going to be machining all the way through when we do the finishing. Check the rapid gaps and the home position are okay. Let's click OK. So let's go ahead and select the vectors now for our boundaries. I'm going to click to select the boundaries that go around the bottom part of our components. Shift and select the other group that we've got there. Now we can come over, and in this case we may be able to get away by just calculating a finish pass because we're planning on cutting foam material for this, but we will go through the process of creating both a rough and a finish. Let's click on the 3D roughing toolpath. I'm going to choose the same tool to do both operations, so I'm going to select a 1/4 inch ball nose tool for my roughing. I'm going to hit OK to take the default settings for that. I don't want to change them in the tool database, but I do want to override them just for this toolpath, so I'm going to click on the Edit button and I'm going to enter a pass depth of 0.25, and I'm going to enter a step over in here of 50%. We'll go quite aggressively with this tool in this particular situation as we're roughing soft material. Let's go ahead and hit OK. I'm going to do Z level, raster X, 0 boundary vector offset because we've already offset our vector. Choose an appropriate name, hit calculate, and then we should see the toolpaths displayed in the 3D view. We've automatically gone into the preview toolpaths form, so we can click the button to preview selected toolpaths. If we want, we can maximize the 3D view and take a look at how those roughed slices would look. Let's come back up to View, tile the windows vertical. I can see I still have my boundaries selected. I'm going to close the Preview Toolpath form. I'm going to click on the 3D finishing icon, and here we're also going to select the same 1/4 inch ball nose tool. We won't need to change tools between the rough and the finish in this case. Check the parameters, 10% step over for the finish. That's going to give us a nice smooth finish on the part. Going to choose the raster option, 0 boundary vector offset again because we've already edited our vectors to take that into account. Let's go ahead and hit calculate. Once more, once that's calculated, the Preview Toolpath form will automatically open. We can maximize the 3D view here, and again with that selected we can click on the button to preview the selected toolpath. Now we can zoom into the 3D view and you can see how each of those slices is going to be machined. As we discussed before, the toolpath is going to go all the way to the bottom of the block, so you need to make sure that you have a way of holding these parts in place while that happens. If we don't do that, then we'd end up with a vertical edge, and when we put the slices together we'd have a lot of hand finishing to do. So this is the correct way, you just need to be aware of it and ensure that you've got a way of holding the part down. If we were happy with the way that looked, we can close the Preview Toolpaths. We could switch both of our toolpaths on so they're visible, click on the icon to save the toolpaths, and choose the option to output all visible toolpaths to one file. Because we're using the same 1/4 inch ball nose tool, we could now choose the appropriate post processor, click the Save Toolpaths button, and we'd be able to output them as one file that we could send to the CNC machine in order to cut all our parts. Let's just undraw the toolpaths again. Let's go ahead and save the file, Save As, and in the project folder there we'll call this sharknest_tp.crv3d just to show it has the toolpaths in it, and go ahead and hit save. So you could open that and see it in the exact state it's in currently. So that just about concludes this example. Let's just take a moment to summarize what we've looked at. We started by setting up a job that was just a little bit bigger than the part we were planning to slice. We then loaded in a piece of clip art, we sized it and adjusted the thickness, and then went ahead and used the slicing function within the software to create 3 slices that would fit inside of 1 inch material. After that we resized the job so it was actually the size of the piece of material we were planning to cut, and we made a copy of our 3 slices and mirrored them. So in effect we had the components to make a left hand and a right hand side of a shark that could be glued together to make a single full 3D model. Next we used the nesting function within Aspire so that we could make 3 copies of our components, so we had enough to make 3 sharks, and so that it could position those parts within our material as efficiently as possible, making sure we had room to machine them. Finally, before we calculated the toolpaths, we generated boundaries for the top edge of our slices and for the bottom edge of our slices, offsetting that bottom edge vector so that we had enough room for the tool to fit down the side of the 3D shapes. Then we came in, checked our material and calculated roughing and finishing toolpaths using the same tool, and showed you how you would save those once you were happy with the way the part looked. And that concludes this video.